Now effect of cutting of a lens on its focal length. See, if this is my lens, if I cut my lens like this or like this into 3 pieces, suppose I take first piece, this is first piece. So radius of first surface is still R1, radius of second surface is R2, and refractive index of lens material is mu. So neither R1 change nor R2 change nor mu change. So focal length of this part and whole lens will be same, because if I write focal length of this, I have to write 1 upon f is equal to mu minus 1. I am taking surrounding air, 1 upon R1 minus 1 upon R2. So neither mu change nor R1 nor R2. Hence focal length remains unaffected. If you write focal length of middle part, this is part 2. If you write focal length of part 2, you will get same result, because this surface has radius R1, this surface has radius R2, and it has a refractive index mu. So neither R1 changes nor R2 changes nor mu changes by cutting. So focal length of this piece, focal length of this piece, focal length of this piece will be same. So if I cut lens like this, perpendicular to its aperture, then every piece has got original focal length equal to original length. It means focal length remains unaffected. But if I cut lens like this along its aperture, suppose this is a lens, its focal length is f. If I cut like this into 2 equal parts, suppose first radius is R1, R1 is equal to R, and second radius R2, this is also equal to R. Then focal length of this lens is 1 upon f is mu minus 1, 1 upon R minus 1 upon minus R, because R2 is negative. So it is mu minus 1, 2 by R. This is 1 upon f. So f will be R upon 2 mu minus 1. This is focal length of this lens, original length, original lens. Now if I take one piece only, either you take this piece or this piece, I am taking second piece. You may take any piece. Now see, first surface radius now become infinity, second surface radius is R. So radius is changed, hence focal length will be changed. Suppose I write its focal length as f prime, so it will be mu minus 1, 1 upon infinity minus R, R2 is negative. So it is mu minus 1, 1 by R is 1 upon f prime. So f prime will be R upon mu minus 1. This is R upon mu minus 1. It means if I multiply, if I move this 2 on this side, then 2f will be equal to this. So here I can write 2f. It means focal length of this will be twice of focal length of this. If you take first part, this also has same focal length as this part. Suppose I take it f prime prime, it is mu minus 1, 1 upon R minus infinity, because R2 is now plane, so its radius will be infinite. So this is mu minus 1, 1 by R. So f prime will be R upon mu minus 1, R upon mu minus 1, you got same result, so it is twice f. So if you cut lens lengthwise along its aperture into 2 equal parts, then each half has focal length twice of the focal length of original lens. And if you cut lens like this, each piece has same focal length as original, because neither R1 changes nor R2 changes nor refractive index of the material of lens changes. So this is effect of cutting of lens on its focal length. Now Now, effect of different refractive indices if used in the to form lens. Effect of material on focal length of lens. Effect of material on focal length of lens. Suppose, number one, I take a lens in which this much part has a different material whose refractive index is mu1, and this part has a different material whose refractive index is mu2. So radius r1, radius r2, suppose I take both radii equal. So upper part has different focal length, lower part has different focal length. The first part, if I write focal length of this part, then it is 1 upon f1 is equal to mu2 minus, suppose I write it part 2. So f2 is equal to mu2 minus 1 upon r minus 1 upon r, because r2 is negative. So it is mu2 minus 1, 2 by r. This is focal length of second part, and this is first part. If you write focal length of first part, it is mu1 minus 1 upon r minus r2, like this. So it is mu1 minus 1, 2 by r. Now see, focal length of both part is different. So if parallel ray is incident on this lens, as well as this part, then its focal length is different. So it will converge light, suppose somewhere here, it may converge somewhere here or away. So you're going to get two images, one image for this, one image for this ray. So two material, two images. Similarly, if I have three different material, suppose this much part of lens has different material, this part has different material, and this part has different material. This is part 1, part 2, part 3. Part 1 has a refractive index mu1, part 2 has a refractive index mu2, part 3 has a refractive index mu3. So focal length of the three part of lens will be different. So 1 upon f1 will be right here, 1 upon f1 will be mu1 minus 1 upon r minus r. So this is focal length of first part. Similarly, focal length of second part, mu2 minus 1 by r minus r, and focal length of third part, mu3 minus 1 by r minus r, like this. So three part has different focal length, you see. If parallel light incident on this, these light will be converge at the focus of lens. So suppose this light converge somewhere here, this light is converging somewhere here, this light may be converging somewhere here. So I going to get three images. So there are three material, so we get three images. If one material is repeated two times, suppose this material and this material is same, then this part and this part has same focal length, so their images will form at the same position. So if this part has and this part has same material, this part has different, then we're going to see two images. So if one material is repeated once or twice or thrice, it will form image at same place. So how many different material is used to form lens, that very image is going to form by this lens. So remember this thing. But if I put material not like this, here this ray is totally influenced by this material, this ray is totally influenced by this material. So this ray is not influenced by this material, or this ray is not influenced by this material, this ray is not influenced by this material. So it is passing ultimately through only one material. Now if you put material like this, suppose this is different material, this has a refractive index mu1 and this has a refractive index mu2, then its focal length will be only one, because the ray that is passing through first material will also pass through second material. The ray that is passing through first material will also pass through second material. So both material working on all rays. So every ray experience effect of both material, so they are going to converge at same point. So in this case, if refractive index, if material of lens is placed like this, then you are going to see only one image. If it is placed like this, then you are going to see different images. Number of material is equal to number of images. So remember this thing also.